Hello everybody. This video is a follow-up on my previous tutorial on drawing the cylinder on its side, the construction and perspective rules. So you can see that I already have the drawing. That's from the demo I did. Now I'm going to tell you how to use the rules of perspective when we are drawing a cylinder and apply it to everyday objects. Another video will be coming up on how to draw the cylinder positioned vertically, not on its side. I will do the demo of homework and everyday objects for both standing vertically and on its side. So recently I got a little bit sick. Well, actually I was very sick. So I was forced to seek help of medical professionals and was prescribed some medicine. And when I looked at the medicine bottle, I thought, this is a perfect cylinder. We have the cylindrical body and the lid is another cylinder, just slightly wider and not as tall. So I thought I gotta save this bottle and explain how to draw that according to the rules of perspective we learned in the video on the vertical cylinder construction. Now that lesson I already taught. Unfortunately the audio on that lesson didn't save, so I'll have to do it again for my next set of students, and that's when it will come out. So again, I like to use an orange marker for my horizon line. Now when you draw everyday objects, you don't have to do the horizon line. This is strictly for practicing when we're learning the main rules and training the eye. So I'm going to construct this pill bottle. Here's my, supposed to be red, but it came out purple because I drew so much over everything yesterday. So, all right, this is our vanishing point. Remember that for the vertical cylinder, the vanishing point can be right down the center. And this is our center line. Almost straight. My lines don't come out too straight on the dry erase board because I'm always trying to reach carefully over the camera without bumping it. Alright, so here we go. So I'm looking quite a bit down and I already know where my eye level is. As you can see, this here are the pins for the eye level of my student who is a bit taller than me. My eye level is quite a bit lower. My eye level is somewhere in here. And therefore, knowing that, I am going to position the bottle I'm looking at quite a bit lower. So again, this is for the purpose of training the eye. Once your eye is trained, you don't have to draw horizon line, vanishing point, and you don't even have to draw the rectangular prism into which it fits, because your eye is trained and you already see everything you need to see. This will be the front of the rectangular prism into which our cylindrical pill bottle will fit. So let's say that we are going to make it about this wide. Why am I making it about this wide? Because if this is the rectangular prism into which the bottle, cylindrical bottle fits, then the cylinder itself is going to be slightly narrower. It's not going to be quite as wide. And I'm scoping out the proportions, right? So I need to hit it to where this is quite a bit narrower than it is tall, plus allowing for a slightly wider lid. So, for example, if you want to do a completely comprehensive study of this pill bottle, even though it's a small sketch and homework, you can measure the width of the lid, compare it to the height of the bottle, and based on that, scope out that first main cylinder. So I'm measuring it, side measuring from here, and I'm seeing that the width, so let's say I'll take this width, fits into the height, entire height of the visible bottle. One, and yeah, it's about like this. It's not quite 2, it's more like 3/4. All right, so far I'm capturing proportions. All right, that's good. So this will be the width of my lid. The bottle itself will be just a tad narrower, but we'll get to it later. So let's construct our first cylinder with the vanishing points in mind. So if we just connect this to here, but this is our entire height of the visible cylinder, which means from here to here, then if we continue constructing, we'll be forced to push the cylinder further out, right? So obviously we shouldn't do it this way. We should aim for our lines from the vanishing point to come to somewhere in here, and this rectangular form here, this shape, should be about the visible opening of the top of the lid. All right. How can we be sure that we allowed enough? How can we be sure we didn't allow too much or too little? So we can put the first guess, look at it, and then playing go ahead, look at the bottle and measure how the opening sizes up. So what I am seeing when I'm measuring is that this opening, the amount of how much we see of this plane is about the same height as the height of the lid. Is about, it fits in another, so 1, 2, 3, 4, and a little bit left. So not 5 times. So which means we need to make sure that this distance here is about the same distance as the height of the lid, and then fits in about 5 times and a little tiny bit. So that obviously looks like this is too much. So let's shave it off a bit, and let's see if this is going to be good. So if this is our distance here, let me just get a shorter pencil to measure. There we go. So here we go. I'm measuring this opening plus another one, plus now it's 3, now it's 4, now it's 5. Seems like a bit too much. It's almost 6, but we don't want it to be almost 6. We want it to be 5 and a little bit. So you see how little actually, how little it has to be shaved off here. 1, 2, 3, 4, 5. Still seems too much. So lower it once again to about here. Now let's see, I'll measure with this, so I could now start marking it as well. So 1, 2, 3, 4, 5, and it seems like I've gotten this a bit too wide. Okay, here we go. Now it looks about the same size. 2, 3, 4, 5, and a little bit extra. I'll go for that. If you want more precision, you can do more precision. So that means that right in here will be the boundary of my cylindrical lid. This will be the elliptical shape. This will be elliptical on the bottom for the height of the lid. That's this part. And the rest will be the bottle. All right. So that means that now we don't need to focus so much on this. Let's even just get rid of it. Get rid of it. And focus on how this connects to our vanishing point. Okay, more or less connected. Okay, good enough. We can now draw this front of the rectangular prism. We can now see that this will be the back of our rectangular prism. Trying to stay very light. And now if we connect the sides of our rectangular prism, again to the vanishing points, it's going to be a lot of lines very close together. But the main portion, we need this right here. See how steep this angle should be to be able to connect to the vanishing point properly. Okay, somewhere in here I got that. So that means clean up this a bit, but we'll just focus on this part. Pencils, paper is much easier to achieve this. Let's get rid of that. So look what is happening. We have this line coming down, we have this coming down, and they intersecting somewhere in here. So that means on the other side, being completely symmetrical, a very similar thing is happening. And if this angle is gotten correctly, according to this line of perspective, then they all intersect at the proper place. So in your sketches, you can do this very lightly. This is why I'm doing it in red, so that you could distinguish one object from another. The box is done. Now the next step, we'll find the center. Rotational center has to go through the diagonal intersections. Here we go. Our diagonals supposed to intersect, if you drew everything very nice and straight, right here. And same thing is happening at the top. We're connecting the corners of the box. And if the lines are nice and straight, they go through the rotational center, which is also the center that connects us to the vanishing point. All right, so we found our rotational center, the main axis. And now we're going to find our minor center. That is a slice this way, also goes through the center, connects this side and this side on that bottom plane of the box. And here we're connecting two sides again. So all of these lines are parallel to each other because they belong to the plane that's going toward that horizon point, vanishing point at the horizon or eye level. Now, as you can see right here, you can obviously see the foreshortening very well because this distance here is greater than this distance here, even though they're two halves. That's your foreshortening. That's what makes it look like a three-dimensional shape on a two-dimensional surface. Here, the foreshortening is also happening. This is slightly greater distance than this. It's just less noticeable because it's just smaller shapes and distances. That's all. All right, so what are we going to do next? Next, I'm going to use green to construct my regular cylinder. So here we go. We know it has to go through these points. It has to go through here. This is where the cylinder touches the sides of the box. And now we need to connect it with a nice elliptical shape, elliptical following line that is symmetrical over the main axis, rotational axis, and our main center, major center for the cylinder. Could be better, but I think you got the point, right? Okay, so same thing on the bottom. And as you can see, because of the perspective, the bottom is much more open. And that's not the actual elliptical of the cylinder itself. Not quite yet, but we're getting there. It's close. Now, all right, I'll leave it at that. So now you see where it does the touchdown here and here. This is the side of the cylinder that concerns us. It doesn't quite line up with the corners of the box. It fits right in between. All right, keep it this way. So that means that out of the whole pillbox, the lid is the one that's gonna follow this setup, the cylinder we drew. The lid's gonna stop right here, right? So construct the bottom of the lid in much the same way as what we did here, right? So if it intersects the box right here, then you can see how the perspective lines are following very close in here. They're going to be showing up right in here and right in here, super steep. But we're only concerned where they intersect the back of that box, and it seems like it lines up right with the front here. It just so happened where this turns and intersects the back vertical, it lines up with the very front edge of the box. And that means it's easier for us to continue drawing. We don't have to draw another line in there. So again, let's, you can see that this is slightly wider Oh, it's almost the same. Okay, so that just is determined by the thickness of the lid of the box. So it's not wider, it's about the same. All right, so this back line happened to line up right at our measurements, so it happened to be the same measurement. It could have gone just a little bit higher, so it could have been just a little bit wider. And I think because of the rules of perspective, and if we drew everything on a larger scale and were able to do it more precise, that's how it would be. Because this bottom should be open just a little bit. So let's aim for that. Let's imagine it's too close, too many lines to draw. Let's imagine that the bottom, the back of the elliptical came to here. And based on that, the corner would be here and right in here. That means if we connect them now, we will find our center. And it intersects right on the rotational one, and it gives us this half and half. All right, now we can construct the front curvature of the pills box lid. I am not going to go in the back. You could if you're doing a nice larger drawing of this. I'm going to end it here so you don't get confused with what you see. I'm going to make this darker, more solid green, and that becomes our front of the box, front of the cylindrical pill box. All right, so what are we going to do now? Now, because the lower portion of the pill box comes within and underneath the lid, the distance there is not very great. So I'm just going to guess. I'm going to, since this is our minor center, I'm going to guess that if I start dropping a line from here on down, this will give me enough of that zigzag where the bottle shows as coming out from under the lid. And I'll do exactly the same distance in a very symmetrical way on the other side. As long as it's symmetrical and as long as it's parallel and coming and hitting our minor center here. And that will allow us now to construct the elliptical within here. How do we know where that elliptical will stop, for example? Well, we know that through this point has to go our lines for the perspective toward the vanishing point. So if our line for the vanishing point is doing something like this, then it will go through this point and toward this edge of the box, as if there was a smaller box within the box. So you see how, well, maybe this is not quite exactly super straight, but it's close enough. And so same thing will be happening on the other side. I will only do it by symmetry rather than going all the way and figuring it out precisely. All right, so this is good enough. So you see how we now have a smaller box within it, but we have to shave it off right at this intersection. So where this diagonal comes to this corner, nope, a bit lower, right here. That's where it was. This one intersects that diagonal here, and this one intersects it here. So our inner box for that smaller elliptical is going to be here. And where is it intersecting that? And this diagonal, but right here. So now we have a new inner square that is foreshortened according to the same perspective, and therefore see how this side of this box is coming to here, right to our minor center. And now we can construct our elliptical within it. All right, I'll call this good enough. So now for you to be able to separate all the lines needed and unneeded, I'm going to go over with blue, just the pillbox. If you were sketching, these are the lines that you would make nice, even, and thick and dark. All the rest of the lines would stay lighter and not as easily visible. Visible so you could train your eye, not too visible to where they interfere with the main structure of this pillbox. You see how this works. Now everything is constructed according to the rules of perspective. All the elliptical shapes are the proper openings, proper to the perspective, to this angle of observation. If you wanted to add further labels and things, they will still go according to this elliptical shapes, opening up more toward the bottom and less open toward the top. By now, once you've constructed all of this, it would be easy for you to guess based on the knowledge. So if you wanted to have something saying on the bottom some label, you can plain follow this curvature, add a label of however length you want. Let's make it go all the way and beyond the edge. And that will be your label that has whatever stuff written on it. It will go with that curvature. All the lettering will also follow this curvature, and the verticals in the lettering will follow the verticals that are parallel to each other. All the diagonals in the lettering will be therefore following from straight to straight, but they will all line up with the curvature. If you wanted to add labels on the top, and right now on that pillbox, they're all going kind of at this kind of angle from where I'm looking at it. So I'll put that line through the center. And now, actually, all the lettering that is parallel to each other on this top will also be connected to the vanishing point over here. Kind of like this. Another vanishing point way over there. And by the time this angle gets here, all the other lettering, if it's still going in this direction, will also connect to the vanishing points and follow the elliptical on the edges. All right. I hope this was helpful for you in doing some simple homework. As you can see, I constructed it all in one take, and 30 minutes. You can safely dedicate 30 minutes to doing homework just like that and select a very simple object like a pillbox, any vases that are practically straight and cylindrical, any coffee mugs, and anything that is following just the straight cylindrical shape. Completely straight. It's not opening up, it's not tapering out, although that is also, those shapes also follow the same rules. So if you liked this homework, if you liked my other videos, definitely comment, share, subscribe, and I would love to hear if you have any questions or difficulties, because when you ask questions, not only you learn, I learn what I didn't explain in a way that you could understand easily. So for the next assignment, let's take something that is very similar but slightly larger. So it's pretty much cylindrical, straight up and down, very similar to my pillbox, except not as tall proportionally. And so let's do it this way. Now we'll do homework for cylinder on its side. I'll utilize the same horizon line and position my box here because it's about the same distance from the eye level, since it's sitting about on the same plane here. All right, so that means I can continue and borrow this boundary. That means my cylindrical shape is not going to go below that. In the same way as I constructed over here, I am going to construct my box first. Let me do it a bit taller than a pillbox. Let's see, if I pick an angle that is kind of like this, will it be a good angle? That means that in the other direction, much like I did it over here, this is going to be a lot more mild. I'm seeing a lot of this side. So in this direction, it's not making as strong of a turn. That means that on the bottom, it's going to be slightly stronger, right? Because it's perspective. All right, let's go with that. So since this is our boundary, I am going to shorten this somewhere in here because I need to transfer this line. This line here, it needs to be transferred because I borrowed this level here, as if I put the pillbox and that new box, cylindrical box, on exactly the same level, same place. If I was just constructing it for the sake of practicing construction only, not reality, not focusing on where I placed it exactly, I could just go ahead and construct my rectangular prism in its place, but I didn't do that. So basically, I'm going to say this is going to be the opening, I think. How am I going to determine whether this is the right width that I chose? I need to determine how much of this I'm seeing compared to the height, right? This measurement compared to the height, compared to how much I see of the rest of the box. So that's what I'm going to do. I'm going to do side measurement. And I'm seeing that, much like in this drawing, my height is only a little bit wider, a little bit greater measurement than the width. And when I compare my width of the top of this box compared to the rest of the box, it seems like I'm only seeing half of it. So let's see, I'm seeing half of the measurement, right? Here's 1 compared to here, 2. See how it's a little bit shorter? Good. So that means this basic width compared to a height would be good. However, we are moving this, right? So it's going to be changing, but we're going to be borrowing this as our true measurement of the height. So now let's compare this to the width. Still is slightly taller. So we'll keep this width. Okay, so I hope you understand this nuance, because you will definitely run into issues like that. What do you start with? What do you keep? What do you not keep? If you have any questions, like rewind, try to listen again, see again. And if you still don't understand, just let me know in the comments. So now I am following in this direction according to the rules of perspective. See how they are nicely getting closer together, but not super close together. All right. So now we can connect this to our vanishing point. Should be a bit stronger. Okay, that's close enough. Now we need to remember what I said when I was measuring this width of the elliptical opening compared to the height. Now we're using this side. It was a little bit less, right? But when I was looking at what else I see of that cylindrical box, it was only half. So it was half of this measurement. If this is a fairly good geometric half and half, then the box ends right there. Which means this is where our imaginary rectangular prism ends, and we can connect it to this line. Because then, if we draw from this intersection all the way in this direction, according to the rules of perspective, where this is getting a bit closer together at about the same rate, they're all getting closer together at about the same rate, we can then connect, well, we find this, right, which is important because this is going to go down here. But before we do that, we can connect this with our vanishing point. Good enough? I guess that's good enough. And so that gives us a definite back of the box here. We can now drop exactly straight line here. We can now connect this to our vanishing point as well. Come on. Okay, still dipping a bit. Let's go a bit straighter. All right, more or less. Okay, so now it is coming down. It's intersecting right here. That means if we connect this with this, you see how the perspective is coming too far out. It's too out of perspective. Good. So I'm glad you see how this can go wrong, because chances are, if you're still learning, this is going to go wrong like this somewhere in your future. So what does it mean? It means that some of these lines are not very straight, and therefore they give us intersections that are not so good. So what is wrong about this, right? What is wrong is that it's coming down a little too low, and it needs to be raised to fit within this perspective nicely. But if we raise it, then look how high the bottom will go. This will go out of whack, right? Don't worry about it. It means that probably the next culprit is this, because if this line were to be moved over here, it would intersect higher with the bottom. So chances are that all the lines are just a little bit off, probably starting with this one. So let's try and make a better line. And what's a little change over here amounts to a big change further down, right? So let's focus on getting this line better. See by how much it moved. Good. And actually, logically, if you think about it, this distance here should get smaller and foreshortened by the time it gets to the back wall, right? But where we had it here was a bit too close. It was too close to being the same measurement. So that's definitely not good. So how about we now drop this and see how it intersects here now. Remember how this was dipping a bit? I still feel like it's dipping down a bit. So let's fix it. And it just got changed just by a little bit. All right, is this also a good straight line? All right, a bit better. Good. So now we can connect this intersection with this intersection and see what we get. Still a bit low, right? But not so bad. It's only bad compared to this here. So let's focus on going a little bit higher over here. Because a little change at this point, this is the beginning of the angle which this line follows, is a big change overall as it goes further away. All right, it's starting to look a whole lot better. So let's do that. We will focus on this here. We will make sure that this is our better angles of inclination for these lines. And we will focus on these intersections here. And now we got a lot better perspective. Let's also remove this line so it's not messing with our additional perspective, because that one also could be perfected, but I don't want to take the time. It's not necessary. This line could be straightened out a bit because it's starting to kind of jump up here at the end, and that's also messing with our seeing our perspective. Still kind of goes up a bit, right? Stay a bit lower. Here you are. Okay. Okay, so now it's a lot better. It's all coming together. All right, here's our box. So in that box, like we did with the others, we are going to find our center. Remember the super important part is to make these diagonals as precise as you can, nice and straight, so that you find that center spot on, so you're not off somewhere in here. Okay, looks like it also happened to intersect this line, which means it's very helpful because we don't have to draw that line for that center. See, so we can utilize this line for this. It happened to be lining up the back of the box, lining up with our minus center for this elliptical shape. Now if we drop exactly straight line down, we get this one here, and so now we can construct our elliptical. Let's do the same here. Seems like this is a good one. Kind of seems like it's a bit high. Let's see, one. No, actually it's right down the middle, so it's good. Remember that all of these lines also follow with our perspective. That's why it's so important to get all of your initial shapes, all of the ridges of the box, edges, all the verticals, all the horizontals, just right. Get that perspective right in the beginning, and you won't struggle with the rest of the cylinder construction. Here's our straight one. Here's our intersection. All right, so now we can construct the main body of the cylinder. I'll do it the same way as I did with this. First, green. I know it's going to be turning here and here. It's going to be turning, touching down on the box sides here and here. But what do we not have? We don't have that minor center for the 90-degree angle. So let's put in our axis, our main center, major center, rotational center, which also should point toward the vanishing point. Kind of like that. I don't want to draw everything too close in here and clog it up. And then based on that, we need that 90-degree angle, right? This here is a bit close, but not close enough. So I'm going to draw this line here, and I'm going to draw this line here. Continue it through the center. How is this? Is this 90-degree? And if you are still not too experienced, just take some kind of tool, almost like anything that is definitely square. So for example, I have this sample drawing board. I can stick it in here and see, it's a bit steeper, or any tool. See how this angle could go down a bit more here. It's close to 90-degree, but not 90-degree. Okay, here we go, that's more. That is more of my 90-degree. And if it's going exactly straight, it would be 90-degree and giving me the right 90-degree angle on this other side as well. By the way, notice that it should be about the same distance here and here where it intersects the box. So this still could come down a bit more, but this right here, let me see, how can I do it like this? This right here, this is pretty much perfect 90-degree. So that means that it still needs to go a bit lower here. There. So you notice the distance from this corner to this intersection. It should be the same as from this corner to this intersection. See this distance? it should be exactly the same measurement. If it isn't, you have to keep adjusting it, because this axis for your cylindrical elliptical shape is very important. If it's not the same, that means the line is not quite straight. All right, now we see that. We can draw a 90-degree line through here, which should be exactly parallel to here, and it should be the same distance from now this corner and this corner. So it's not the same distance as here, but it's the same type of distance, only foreshortened here. So if you just measure your rectangular prism, it will be exactly the same measurement. But because we're drawing it on two-dimensional surface, imitating two dimensions, it's foreshortened. All right, I'll go for this now. Okay, now this is 90 degree. And so now we can construct our main elliptical shapes, focusing on this and on these intersections here as being 2 half and half. You can throw in something first, like you're guessing, knowing that there are touchdowns right here. And then you can start polishing it up and making it more smooth, even looking. And that's where you're also training your eye. Okay, if we're doing it like this here and like this here. By the way, that means that this distance and this distance also have to be the same. See how it looks a little pointy here? Let's shave it off. It's slightly less pointy here. Smooth it out. So basically, if you take your drawing and turn it with this being completely parallel and flat, this elliptical should look as if you constructed this type of ellipticals just by looking at it vertically. It should be very, very close. There's so little distortion happens in this elliptical compared to when it's just vertical. There is still a little difference because it's foreshortened this way, not foreshortened this way, right? So it is foreshortened slightly this way because this is further away and this is close, but the greater foreshortening is happening this way. So this is why these two sides are symmetrical to each other, but they are almost, but not quite, as if you turned it and positioned it vertically with the axis lining up with this axis. Okay, I hope that is clear. So the same thing, let's throw in approximate line here. And now we can start making sure it does what it's supposed to. Too pointy, too pointy. All right, too close to this edge. Needs to veer off sooner. Needs to have a good touchdown here. Seems like this is all right here. perhaps a bit too far over here. All right. I will keep it and call it close enough, because eventually this is not going to be our main part, right? It's going to be like here, pushed a little bit in. So now that we've got that, we can connect the sides lightly to here. And this side and this side. So basically this is the interior of the box in here. And this side's, let's not connect them right now. Not quite needed yet. So we are going to keep this as our top lid. And we're going to get a little thickness added for the lid. Now at this angle, I can see that without even measuring, I can pretty much figure it out. So if I keep the width of the lid at this much, it will fit in here 1, 2. It's kind of like what I'm seeing. So let's do that. We'll say that the top lid from this angle of observation leaves us 2 of the same measurements before the edge of the box. So now let's construct this elliptical. I don't want to draw another square, but you could draw another square. It's just I already got so many lines in here, and it's going to be harder to see. For example, this is the, remember, this is our top of the box, right? This is where our edge of the box is, that ridge coming toward us. So that means that the lid is going to be right here. It's going to be right here, also according to the perspective. And I'm not going to draw it inside, but you can see how it all adds up. You could draw it. You could draw everything really thorough, but it doesn't have to be. So that means that this is our other axis, right? Minor axis. And it goes toward here. So that means this is going to be our main part where the lid touches down. The other touchdown is going to be right here. The other touchdown, didn't draw the inside of it, will be right on that center, right here. Let me in fact do it in red, because this is all part of the box structure. And from here, if we connect it to here, this will be our other touchdown. This touchdown here is less necessary, but it's a good place to keep an eye on, because we are now mostly following our line over here. Whereas the other touchdown right here. So we know we have to go through here, and then we'll go and dive down. It's at this angle. What is happening is that you are seeing this curvature almost the same way, replicated just a little step away. A little step sideways and up, which gives us this as the edge of our lid on the cylindrical box. This edge, the reason I connected those two in this direction, because we are going with that plane. It's going to go to that vanishing point. In the same way, when it hides here, if we connect the very visible edge, which is we're starting not to see any edge past this point, if we just connect that plane with a line that is conforming to this plane, then you will see how this curvature will die right into that straight line. That is the edge of the pillbox. That straight line has to be pointing to the vanishing point. Okay. This may seem like a lot more complicated, but take it step by step. Don't rush and just take the time to try to understand what is going on. If you take the time now and don't rush, you will get your eye, hand-to-eye coordination trained. You will have an easier time later. It's better to have easier time later with complicated shapes when you're drawing it for painting and you don't want to spend hours and hours on drawing it out correctly and then paint for hours and hours. You want to learn to do it quicker, train your eye sees where you're off. You don't even have to complete all of this construction. You already see where and how you need to do it. All right, so the smaller diameter for the back, let's plainly cut it off. Let's say we'll cut it off right here. We'll just make it very much shorter. For the sake of ease for you to see it, and hopefully this is easier to see, I will make it less of a diameter than what I see there in reality. All right, so on the height, I shaved off quite a bit. This distance here is how much of the diameter we are giving up, right? To make the box itself narrower than the lid. Over here, it's foreshortened, so it's not quite the same. Let's just plain estimate how that square is going to fit in here. So if we draw this line here through the distance we are eliminating, and this line again is good with our perspective, then it intersects the diagonal right here, then it comes up this way, intersects the diagonal here, then again within the proper angle for our perspective, it's coming here, intersects the diagonal, comes down and intersects this diagonal right here. All right, so we constructed that inner square. Within that inner square, we can construct our elliptical. We already have 90 degree. That line did not change. So this 90 degree angle line did not change. It's part of the same plane, part of the same side of the box, rectangular prism. So now we just know that it's going to go through here. It's going to be touch down here, touch down here, touch down here, and touch down here. Now I will go ahead and switch to my blue marker, like I did here, and complete the construction. This is my elliptical here. And you see how this inner elliptical is much easier to do because I have that outer green elliptical. This fits in nicely. So if outer elliptical is already constructed, nice and even, I can fit that. That's going to go right in here, but I don't want to overdo it because I'm already doing the inner construction, or what we see, actually, the final. This side stays. This side gets connected. So you don't even have to connect it all the way, as long as it's following the same perspective, heading for that vanishing point. As long as this one is heading for that vanishing point, you can stop it right at the edge of the lid. This is the lid overlapping the box, lid edge. This is where it's becoming straight. This is where it becomes straight. This is where it's elliptical. And pretty much this is it. If I could make it darker, that would be great, but my marker doesn't want to cooperate. Going down, it cooperates. Drawing downward. No, no. All right. I will let my marker rest. Maybe it will come back to life, and I could punch up some of these lines. All right, standing back, I see that this line is not quite, it's a little bit out of shape. Okay, there. Needs to be within that proper perspective. This is all right. All right, do you see how, because I brought this in quite a bit instead of just a tiny bit, like on my actual box, I did that for the sake of you seeing the nuances of drawing. It is, otherwise it would have been very hard on the scale with these markers for me to show you how to narrow it down but keep it within the same perspective and the same rules of these elliptical shapes. When you are drawing it, you can draw this larger. You can obviously make it more realistic. All right, I guess this is as dark as my markers will allow. So if you wanted to show the curvature, if there are any labels again, they will be all following in this direction, and therefore this is how the shadow, for example, of the curvature is going to go. Same thing is going to be happening over here. The curvature, but you can also indicate this, for example, with straight lines. to show that this is your edge of the lid. And if these lines are still kind of directing the viewer to the vanishing point, it also becomes very, very helpful. All right, same thing if you want to add any labels to the top of it, you can utilize this exercise. You can find that if for example, the label goes at another angle, it will be helpful to find the angle, put it through the middle, and then add whatever the design of the label with the same angle in mind, angle of inclination, and the curvature of the label will follow the curvature of the lid, just more inside, right? If the label was kind of on both sides of the center, you can do it this way as well. So your label would be here, stopping here, and if it's flat, cut off here and here. I hope this was helpful again. If something was not clear, if you didn't understand something, leave a comment or question in the comment section. I'd be glad to answer it. And based on your comments and based on your questions and what you didn't understand or something wasn't clear, I will adjust how I teach, and I will be including more and more of the information that is commonly misunderstood or still stays a mystery in my next tutorials. So thank you very much for watching. I'll see you in the next one.